So hopefully after yesterday's lesson, you're ready to begin our discussion on the details of glycolysis. You'll hopefully remember that glycolysis is happening uh, just outside the mitochondrion in the cytosol. So we haven't yet penetrated the interior of the mitochondrion. The initial processing of glucose is happening outside in the cytoplasm or the cytosol. So let's get started. So glycolysis, if we're looking at it from an overall perspective, if you really had to sum it down to the bare bones basics, then you would say that the point of it is to take our fuel molecule glucose, a 6-carbon molecule, and to break it down into 3 carbon compounds, 2 of them, each with 3 carbons, and those are called pyruvate. And by doing that, you're releasing enough energy in breaking those chemical bonds and rearranging the molecules slightly that you can start to build some energy stores that can be used a little bit later on to get some mega ATP payoff. So really, again, the basic process of glycolysis, what it's all about is to take the 6-carbon glucose and end up with our 3-carbon pyruvate molecules, 2 of them, that will move on to the next stage. I thought a lot about how I was going to present this to you, and when it came right down to it, I'm going to provide you with the skeleton note for this first part, which is our introduction to the specifics of glycolysis. But I think when we get into the details of glycolysis, it's going to be really important for you in terms of retention to be writing down the steps. So I'm going to encourage you to be writing down the steps, pause the video when you need to, and indicating some information. But I'll let you know when we're ready to get to that point. So at that point, you'll know to stop the video. So by looking at this diagram, it might seem to you, okay, well, that's not so bad, just go from here to here. But the reality is that this is actually a 10-step process, and each process is catalyzed by a unique enzyme. So that's where the details come in. This process is actually considered anaerobic. The rest of cellular respiration, like the Krebs cycle, pyruvate oxidation, and electron transport chain and chemiosmosis, all require oxygen, but glycolysis is in fact anaerobic. And so that's important to consider, and we'll get back to that fact and how it impacts certain living things a little bit later on. We can also describe it as being catabolic. Now remember, catabolic reactions involve the breakdown of substances, and I think we can see that clearly with our 6-molecule glucose being converted into 2 3-carbon pyruvate molecules. So we're definitely going from a complex molecule to a more simple one, and in so doing, releasing some energy that can be trapped in the form of ATP. So we can say that if we're really looking at what's going in and what's coming out of glycolysis, we can sum it up in this overall reaction. So we're going to start with 1 glucose molecule, and it's going to, of course, end up as this 3-carbon pyruvate over here. We're going to start with 2 ADP molecules, adenosine diphosphate, and 2 inorganic phosphates, and we're going to phosphorylate that ADP with those phosphates, and that's going to create our 2 ATP, adenosine triphosphate. Now, another really important step that happens in glycolysis is that we end up taking our NAD plus molecule, our electron carrier, and actually getting it to carry electrons. And so NAD plus ends up being reduced in this process to NADH. Again, remember that our charge is being reduced. That's the key to remind you that a substance is being reduced when we see that charge reduced. So as a result of that, we have 2 hydrogen ions that are going to be released from our glucose intermediates, and one of them is going to attach to NAD plus to form NADH. And the other one is going to be just sort of floating around in the cytoplasm, as we discussed in the last note. So typically speaking, glycolysis is separated into 2 major phases or sections. And the first section is the energy investment phase. And I sort of think about this as though, like, if you're investing money, right? So in order to make money, sometimes you need to spend some money or invest some money, right? Except that our currency here isn't dollars, it's ATP. So in the first 5 steps of glycolysis, what we're going to do is we're going to input some ATP. And that's our investment. And we're hoping that by investing that small amount, later on, we're going to recover that ATP and make even more ATP. So that's why we call it the investment phase. We're going to just invest a couple of ATP at the beginning in the hopes that we are able to have that generate more ATP. So for that reason, the second phase or section of glycolysis, which happens in the last 5 steps, results in 4 ATP actually being produced. So we've invested 2 and we've made 4. So let's just do the math on this. You know, not too hard math. So we put in 2 in this first stage and we end up with 4 ATP being produced as a result. And so overall, if we look at that, well, how many have we produced? Well, we put in 2, we ended up with 4. So we have a net gain of 2 ATP. Okay, in terms of our accounting. So we put in 2 ATP, we invested 2, which gave us a payoff of 4. So overall, we have a net ATP gain of 2. Hope that makes sense. Now, another important point that we need to mention is that we also have some two NADH molecules that are going to be produced. Okay, so those NADH molecules are carrying those high energy electrons, and we're going to use that the energy of those electrons to create mega ATP in the final stages of cellular respiration. But it's important to know that NADH undergoes a conformational change and becomes an FADH2. You don't need to understand the mechanism for that, but it does in fact happen and has a bearing on how many ATP we can eventually end up with. So, but that's the point that we'll go back to, and we'll make sure that you understand when you really need to understand it. So at this point in the lesson, I'm hoping that you will turn to page 172 in your textbook and follow along with our diagrams. I'm not really too keen on the way that Nelson has decided to put these diagrams in. I think that it leads to more confusion that doesn't actually need to happen. But by the same token, I really like the way that they've laid out the structural models at each stage. So I want you to be able to refer to that. But I also want to simplify it for you. So I'm going to, while you're hopefully flipping to page 172, again, feel free to pause the video at any time just to keep things nice and tidy for us and clear, and that everybody is able to be caught up. What I actually prefer is this diagram right here. I'm just going to change my screen here a little bit. What I like about this one, and I would have given you this outright, except that the quality of it when I try to print it out ends up being really, really poor. So I've sort of configured my own and written some additional notes. And so what I want to point out to you is here's my 6-carbon glucose, and eventually we split it, and you can see it actually like a fork in the road. It's splitting into 2 halves with the end of it with this 3-carbon pyruvate. I'm going to talk really soon about all the details in between using a more clear diagram, but I just want you to compare this to your textbook and what it looks like. So, you know, really what's going on in this textbook is it starts up here at step 1, and then instead of going on the next page, it just kind of goes up. You know, it says continue from reaction 5, and we go on and on and on. It doesn't show a fork in the road, but I want you to remember that every time it says 2 molecules underneath, that's where the fork in the road has happened, and you actually have, this whole process, step 5 to 10, happening twice. So I'm going to go back again. So in this nice blue diagram that I'm seeing here, it shows glucose, and then it shows the fork in the road where glucose is split into 2 pieces. Your textbook does not show that. It just assumes that you'll understand that step 5 through 10 is actually just happening twice. So I want to be able to start the next lesson without any interruptions or pausing mid-video. YouTube only lets me make videos up to 15 minutes long, and so what I want to do is I want to stop this video and begin a new video, starting by breaking down glycolysis, so that we can kind of not have to shuffle between different videos as we go through. So what I'm going to need you to do is get a piece of paper ready to write down the notes as we go. I'm going to show you a simpler diagram of glycolysis that I can certainly provide for you on Google Classroom, but I also want you to have your textbook open, following through the diagrams in your textbook as we go through. All right? See you in the next video.